And now it is time for a sample problem. Over here in the lower right, I've included our Molar roadmap. You'll notice that I did not include liters. I also did not include atoms because, as it turns out, we're not going to use those very much. So let's see what we have in store. How many molecules in 141.2 grams of sodium phosphate? Oh no, alarm bell's going off. Sodium phosphate is in words. This is science class. We want formulas. So naming rules for sodium phosphate. Na for sodium. Our good friend PO4, the polyatomic ion. 3 minus for the charge. 1 plus, which means we do the crisscross disco dance. Take that charge, put it down low. Take that charge, put it down low, and do some disco while you're at it. So the final is Na3PO4. This 4 is not from the disco dance. It's just part of the polyatomic ion. There's an invisible 1 on the outside. If you would have needed a bigger number around that polyatomic ion, you would have had to put parentheses. We didn't need that this time. We got lucky because it was a 1. So this is the monster we're dealing with. And we need to set this up as a dimensional analysis problem. There are 3 ways to go about this. I'm lazy, so I'm going to use the most efficient one. And that is called the chicken ladder method. It starts with a big bar and some hash marks. It's kind of like that movie where they ran up the ladder and they launched off into space or something amazing, except it's just chemistry. So this is exactly the same as this, multiplying fractions from way back in 6th or 7th grade. So you could choose to write it like this, or you could allow the close parenthesis, the times, the open parenthesis, they all blend together into this one single line. Pick whichever one you're more comfortable with. Like I said, I'm lazy, so I like to write fewer lines, not more. Whenever they give you a number in the problem, like that, 141.2 grams, that always goes in the upper left. If you want to include the label as in Na3PO4, you could. Your teachers would probably like it a lot, but I'm lazy, so I'm not going to. Now, once you write this number that was given in the problem down, you will not use it ever again. So even though it says grams, and you think, hey, I'm trying to get rid of grams, maybe I should put 141 down here, that's not right. You just use the number given in the upper left to start things off, and that's it. Never copy it down a second time. So then what does go down there? Well, this is where we need that Molar roadmap. Oh, wait, the office building, right. We need the office building. So which office are we starting in? Because that's got a G, we're starting in the grams office. So down here, we need to leave from the grams office. And because the original question asked for the number of molecules, we need to go to the molecules office. But no, there's not a hallway. Well, that's okay. We're just gonna have to make an extra stop in the moles. So if there's not a line drawn, you cannot go straight there. You have to make an extra stop. And believe me, this will get more complicated later, but that's why we need to envision some sort of picture that you can imagine walking yourself through. So the office you leave goes in the denominator, the office you walk toward goes in the numerator. The password to get past the guard is right here. So we will need the molar mass of sodium phosphate. Get out your calculators and your periodic table, we will need them. And then the number in front of moles at this stage of the game is always a 1. Simple as that. The number in front of moles is always 1. So let's go back here. We are getting rid of grams, so grams goes in the denominator. Now you'll notice that nothing is down here. If you're uncomfortable with that, just put a 1. Not 1 mole, not 1 gram, just a 1. Because anything divided by 1 is the same thing it started with. So that's your first fraction. The number given in the problem divided by 1. We are getting rid of grams, so we put grams in the bottom. We are going toward moles, so moles goes in the top. The number in front of moles is always 1. The number in front of grams is not 141.2. Instead, it's going to be the molar mass. So now we need to figure out how much sodium phosphate weighs. If you look on your periodic table, you'll notice sodium 28.9898. Now, you could just round this to 29. Maybe you want to. I did mention that I'm lazy, so that's tempting, but I've gotten enough problems wrong because of rounding that I'm not going to do that. I will keep all 4 decimals, and I round only at the very end. So keep as many of those as you can, but then you will need to pay attention to significant figures at the end of the whole process. Back to phosphorus. This is 30.97. If we want a tad bit more accuracy, we can harvest those last 2 digits from the periodic table. And then oxygen, turns out that one's actually pretty sweet. It's a simple 16. So when you calculate the molar mass here, always type in the entire thing all at once. It's tempting to use the A and S button on your calculator, but I find it's much easier to just go 28.9898 times 3 plus 30.9738. You don't need the times 1, but if you feel like it, be my guest. Plus 16 times 4. The times comes from the subscripts. So after you enter this whole mess, press enter once, and you should get 163.883. Now, yeah, there might be some more numbers, and I said that I was going to keep 4 decimal places, but now I only went to 3. Okay, I think it'll be all right. From here, this is still grams, and that's the molar mass that is this password. So that goes here. 163.883. And I'm going to let you edit this because that was messy writing. So that number, 163.883, goes down here. And then we have arrived at the mole's office. Now that is not where the problem asked us to go, so we need to keep on moving. The next office that we're going to leave is wherever we're currently residing. We leave the moles, so moles goes in the denominator. We're walking toward molecules, so that goes in the numerator. Now we need the password. What's the number in front of moles? Oh, that's right. Always 1. What's the number in front of molecules? This is the only time that you actually get to use Avogadro's number. The hallway between moles and molecules, that diagonal bridge, is 6.02, E23. From here, all of your units should cancel diagonally except the one that you want. Grams in the numerator, grams in the denominator, moles, moles, same exact story, but we keep molecules because there's nothing to cancel with it. From here, you multiply everything across and divide by everything in the denominator. If it's a 1, you don't need to input it into the calculator. So this is exactly what I would type if I were using one of the TI 84s or 85, something like that. 141.2 times 6.02 E23 divided by 163.883, enter. That's it, you're done. All you have to do is round for significant figures. So in the end, the calculator should spit out something close to this. Try that again. In the end, the calculator should spit out something close to this. As you can see, there are too many sig figs there because the original problem, if you look way back to the purple, was 4 significant figures. Therefore, when we do our multiplying and adding and everything else, by the time we're done, this should also have only 4 sig figs. So after sig figs, we end up with keeping only 4 digits, which means this number is going to be the one that either stays the same or gets rounded. Taking us to the final solution, (5.187E23). Don't forget, you do need labels or you will probably miss points. What is this thing measuring? Molecules. And molecules of what? Not only do you need to say which office you're in inside the office building, you also need to say what is the substance that you're measuring. In this case, the whole problem was about sodium phosphate, so either write it out in words or just use the formula. And that is the final solution. Congratulations, you made it through the sample problem. From here, try some on your own. I've got a link in the comments, or you can probably use Google to find some other sample problems as well. I hope this has been helpful, and I look forward to making a few more of these for you.